here with you to go over math packet number 4 for algebra. This is due Tuesday, November 30th. Us not being in school next week, Monday and Tuesday. If you want to turn your packet into me on Monday the 29th for me to check over, it won't be due for you until Wednesday, so that I have a night to check it over, you have a day to make corrections, and then you can turn it in. So if you do turn it in to me on the 29th for checking it, it's due on Wednesday. If you don't turn it into me on the 29th for checking, it's due on Tuesday, the 30th. So we're going to kind of go through each page quickly here. Feel free to jump around the video to whichever page you need. If I don't answer one of your questions on the video, then please feel free to contact me. Shoot me an email, and I'll do my best to help you out. The first one here, a drop of water drips from a leaky faucet every 8 seconds. It takes 6 drops to make a milliliter of water. How many liters drip from this faucet in a week? So for starters here, we can take this information and we can say, how long does it take to make a milliliter, right? 1 milliliter is made every 48 seconds. 1 drop every 8 seconds, 6 drops, total of 48 seconds. So then basically what you need to do is figure out how many seconds in a week. Okay? That will be able to allow you to calculate how many milliliters fall in a week. And then you want to convert that, go from milliliters to liters. Okay? And that prefix milli means 1,000. So whatever number that you get here, you're going to divide that by 1,000, and that's going to bring you to the number of liters. So a couple of conversions here. 1 milliliter every 48 seconds. Calculating the number of seconds in a week will allow you to calculate the number of milliliters in a week, and then convert that to liters by dividing whatever that number is by 1,000. So that should get you started. If you have any other questions, shoot me an email. This one's fun. This might be actually one of my, now that I'm a parent, especially soon to be of 4 kids, trying to figure out who done it is always an interesting venture. But one of 4 sisters, Tina, Nora, Rita, and Maggie, drew on the wall of their room. When their mom saw the wall, she asked who drew on it. Rita says Tina did it. Nora says Rita did it. Tina says Rita did it. Maggie says, I didn't do it. It wasn't me. Here's the key point. If only one of the girls is telling the truth, who did it? So what you need to do here is kind of start at the beginning, right? Let's assume that Rita is telling the truth. If Rita's telling the truth and Tina did it, right? Remember, only one girl is telling the truth. If we assume it's Rita, you have to run through the other 3 and see if they're lying. If Tina did it, is Nora lying when she says Rita did it? Or yes, right? She's not telling the truth. So that checks out. Tina says that Rita did it. Well, if we're assuming that Tina did it because Rita's telling the truth, that means that, in fact, Tina is lying. Rita didn't do it. So far we're all set. Maggie says, I didn't do it. Here's where we run into a problem. Because if Rita's telling the truth, and she's the one girl telling the truth, saying that Tina did it, when Maggie says, I didn't do it, well, she's also telling the truth. What does that tell us? That tells us that Rita is not the person telling the truth. So we can eliminate her. And then we go to Nora and Tina and finally to Maggie and see how this checks out so that only one girl is telling the truth. That's not your answer, though. The answer is who did it. Once you find out who is telling the truth, then you can go back and use what she's saying as information to help you figure out who actually did it. Okay? So kind of a real logical question here. Okay? You can kind of get lost in the words easily here, but see what you can do with it. Okay, next up we have the 5-card challenge. That is the same as it's been for every other 5-card challenge. Make sure you are getting 18 points. Make sure you are using an equation with all 5 cards. And just check to make sure that what you write down is actually true. For this one, calculate the percentage of the figure that is shaded. We've got 3 circles here, so it's going to be helpful to know the area of a circle. is pi times the radius squared. And the area of the figure, the whole figure, is the giant circle here, right? So the question is, what is the radius of that circle? Well, we're given some information about the radiuses of the two smaller circles. And if you kind of fill in the diameters here, to get the diameter of the large circle, right? Now this whole thing is the diameter of the large circle. You can get the radius from that and ultimately find the area of that large circle. Then to find the area of the shaded region, we're essentially subtracting the areas of the two smaller circles from the area of the large circle. Subtracting the area of the two smaller circles from the area of the large circle. And of course, remember percentage is shaded divided by total. That's why you find those two things first. To find the percentage of the figure that is shaded, you were just dividing that shaded area by the total area. Next one. Identify the equations that are equivalent to the given equation. Defend your decision. We've been working with equations a lot recently, particularly not only in the solving, but converting from Slow-Burn subform to standard form. So here we have an equation. It's not in Slow-Burn subform or standard form, but it's a two-step equation, 3x plus 2 equals 23. And, is this equivalent to 2 plus 3x equals 23? Well, two ways we can look at this. The answer is yes, right? Because really the only difference is we just reordered the 3x plus 2 to 2 plus 3x. And since you can add things in any order, it's not going to change the value. Not going to change the value of the equation. It's going to be the same thing. Another thing you could do is solve for x in the equation. When we subtract 2 and divide by 3, we get x equals 7. Does x equal 7 in this equation also? Does 2 plus 3 times 7 equal 23? The answer is yes. Okay? So you can either just think about it algebraically and kind of use your properties of algebra here. Is this an equivalent equation? Did I just rearrange something? Did I move something over from one side to the other or whatever? Or you can solve for the variable, get the value of the variable in the original equation, and see if the other equations are true. Okay, so two methods to go about this here. Just make sure that you are defending your decision, so it's not just a yes or a no answer, but it's also how you came up with that. The pattern block page. Your job is to complete the table. And so starting with the total blocks is really probably the best place to start here. In figure 1, we got 1 total block. In figure 2, it's a 2 by 3 rectangle, so we have 6. Figure 3 is a 3 by 5 rectangle, which is 15. Figure 4 is a 4 by 7 rectangle, which is 28, and that's as much as we're given. Okay. We also are given the number of blue blocks in the first 4 figures. The first 3, it's 1, right? Then in figure 4, we add another layer of blue blocks. And just as a reminder, this is not asked for how many blue blocks are added. It's how many blue blocks are there in the figure. So we count what we added. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And the original blue block gives us a total of 14 there. We know it's going to be 14 for the next 2 figures as well, because we're not going to add another layer of blue until figure 7. Okay. We can also get the number of green blocks. First figure, 0, 0. Next figure, second figure, we've got 5 green blocks, 0 red. And notice that our what we have, our blue plus our green, 1 plus 5 adds to equal the number of total blocks. So it's actually probably best strategy here to fill out that total blocks column first, right? Because you know that you've got the same number of each block for 3 figures. And so you can kind of fill this table out in sections. And then if you know the total, you can get that missing piece fairly easily. So the challenge here is, what's the pattern with the total blocks? And I'll get you started here. The first figure is a 1 by 1. The second figure, a total of 6, is a 2 by 3 rectangle. Third figure is 3 by 5 rectangle. Fourth figure a 4 by 7 rectangle, perhaps you see a pattern developing here. And that will help you fill out that total blocks column, and then you can get the individual ones now too. Okay, there you have that. Scrolling on down, about halfway through. Come to surface area. Drawing a net of the figure and then finding the surface area of this pyramid. So a pyramid has that square bottom. It's an 8 by 8 square. And then we've got 4 triangles coming out from each side of the square. So if you folded this flat, it would look kind of like that. And the surface area is the area of all 5 of these surfaces added together. So the area of the square, 64, pretty easy to find that there. Recall that the area of a triangle is the same as the formula for the area of a square, only you're dividing by 2. Okay, base times height divided by 2. So we'll be using this base length of 8 again for the triangle, but we also care about that 16, that height value there. And there are 4 triangles. They're all congruent. So whatever the area of one triangle is, it'll be the same for all 4 of them. And once you calculate all the areas of each of the 5 surfaces, add them all together, and that's going to be your surface area. But don't forget to draw that net, because you need that net there also. On the volume page, the relationship of a pyramid to its 3-dimensional kind of counterpart solid, a rectangular prism. Remember that the formula for a rectangular prism is base times width times height. Well, it turns out that a pyramid, if we were to kind of draw a cube around this, or a rectangular prism around this, that looks rectangular prism-y, not quite, I'm so bad at that. But anyway, a pyramid is a third of the rectangular prism that it comes from. So whatever the volume is of the original rectangular prism that I poorly drew around this pyramid here, the volume of our pyramid is going to be a third of that. So the formula is just base times width times height divided by 3, because dividing by 3 is what can give you a third of something. Okay? So the calculation that we'll perform for this one, base times width times height, 10 times 8 times 6, and we're dividing that by 3 to get the volume of the pyramid, which I'll let you calculate here. Your question for algebra then, what is the volume of a right rectangular pyramid taken from a rectangular prism with base dimensions of 16, 28, and 14? So maybe I can draw a better rectangular prism. I don't already have a pyramid there. It kind of looks like this. Should I go all the way? Like that, like that. Yeah, that's not so bad. Ooh, that's not bad. Anyway, so we have 16 and 28 as our bases and a height of 14. Whatever the volume of that rectangular prism is, the pyramid that comes from it will be a third of it. So I give you the rectangular prism, and I want you to tell me the volume of the pyramid that would come from it. Okay? And that's the relationship between the formulas of a rectangular prism and a pyramid. Next one, we move on to Pascal's triangle with probability. Okay, it's one usage. We've looked at a lot of different usages for Pascal's triangle here. Another big one is determining probability. Here's the situation. It says, consider me flipping 4 coins. You win if you get at least 3 heads or 3 tails. What is the probability you win the game? First, let's consider all possible results. So for 4 heads and no tails, it's pretty much just heads, 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 heads. That's the only possible outcome of that. To get 3 heads and 1 tail, which remember is a winner for us, right? I'll kind of put arrows next to the ones that make you a winner, 3 heads or 3 tails. You can get 3 heads and 1 tail a couple different ways. You can get 3 heads and a tail. You can get 2 heads, a tail, and then a third heads. You can get a heads, a tail, and then 2 heads. Or your tail can come first, and then you can get 3 heads. Okay? For the next one, 2 heads and 2 tails. Well, here, let's start. We got 2 heads, 2 tails. We can get a head, a tail, and a head and a tail. We can get a tail, a head, and a tail. We can get a tail, a head, and a head. I'm going to switch my marker so it's thinner so we can actually fit the rest of these on here. Let's see. I've got I'm missing two of them here. Tail, oh, head, tail, tail, head. I haven't had that one on here. Head, tail, tail, head. And what's the last one? I lost track of my logical order here I was trying to do. Tail, head, tail, head. There we go. Tail, head, tail, head. Okay, back to now. For the one head and three tails, it'll basically be the opposite of what we had for three heads and a tail. All the possible outcomes are here. Okay? And then for 0 heads and 4 tails, that's just one outcome again. Okay? Now, what I want you to focus on here is, well, first let's finish this out. It says, what is the probability of you winning? Well, how many total outcomes are there? We've got 1 outcome here, 4 outcomes here, 6 outcomes here, 4 outcomes here, and 1 outcome here. That's a total of 16 possible outcomes, 8 of which are winners, the 4 and the 4. So the probability is 8 out of 16, which is a 50% chance. You have a 50% chance to win getting 3 heads or 3 tails by flipping 4 coins. Okay? Here's what I want you to notice. Where do you see this series of numbers in Pascal's triangle? 1, 4, 6, 4, 1. Boom. 1, 4, 6, 4, 1. Right? It's not a coincidence that flipping 4 coins brings us to row number 4. Remember, this top row is considered row 0. So for the next one, all combinations for results when flipping 5 coins, how many of each combination are we going to have? Well, if we're flipping 5 coins, we can look at row 5, and you'll have 1 combination for 5 heads and 0 tails, 5 here, 10, 10, 5, and 1 again. So you can then use this information, Pascal's triangle, to answer these 3 questions here. We'll go over the first one together just to kind of get you started. It says flipping 7 coins, how many ways can you get exactly 4 heads and 3 tails? Okay. Well, flipping 7 coins, I know I'm going to row 7, which is right here. Okay. And this represents, this first number is how many combinations to get 7 heads and 0 tails, 6 heads and 1 tail, 5 heads and 2 tails, 4 heads and 3 tails, 3 heads and 4 tails, 2 heads and 5 tails, 1 head and 6 tails, and then 0 heads and 7 tails. So, how many ways can you get 4 heads and 3 tails? Here's my 4 heads, 3 tails combo. That's over the number 35. There are 35 ways to achieve that result. You don't have to write them all. Spirit of Christmas. Okay, Spirit of Thanksgiving. But there you have it. All right. So, filling out the rest of the page. This is as with most of the math exploration pages, probably the one with the most amount of work. But if you are interested in mathematical patterns and connections, it's also probably the most interesting. It's just kind of really cool how many applications Pascal's triangle has. Then we go into possibility diagram. Make sure you are making the possibility diagram when you do this. That is part of the deal. Okay? You've got 2 spinners, each with 8 equally sized sections. So 1, 2, 3, 4, 5, 6, 7, and 8. And 1, 2, 3, 4, 5, 6, 7, and 8. And it says, what is the probability of spinning the same number both times? So that's a successful outcome there. Or a product that is less than 40. So what you want to do is you want to go through this and write in all of the products. If you spin 2 ones, that's a product of 1. 1 times 2 is 2. 1 times 3 is 3. 4, 5, 6, 7, 8 is going to be the same thing across the bottom here. Okay? Then if you roll both 2s, 2 times 2 is 4, 2 times 3 is 6, 8, 10, etc., etc. Fill in all those products. How many of them are either the same number, so, kind of this whole diagonal here is going to be successful for you, right? Or a product less than 40. And of course, probability is successful over possible. So the number of successful outcomes divided by 64, because there are 64 total outcomes here, since it's an 8 by 8 grid. Then we move on to the Tetris page. You know how this one works. And then finally on to the logic puzzle. Clues don't often give you an answer. Instead, they allow you to eliminate wrong answers. Okay? Number one here says, no pie has an alliterative name. Alliterative name, right? What that means is that like no two, the pie name and the flavor can't start with the same letter. Letter. That's what alliteration means, starting with the same letter. So we can eliminate blueberry bonanza. Can't start with B's. Can't be strawberry surprise. Can't be strawberry slice. And it looks like I think those are the only alliterations that we have here. Sometimes it does give you an answer directly. Number two here says, when added together, one pie has a 10-letter name. Well, the only combination that works for is apple slice, right? So this has got to be apple slice, which means we can eliminate apple explosion, apple surprise, apple bonanza, apple delight. I don't think I ever want to eat a pie that has the word surprise in it. Apple surprise! This isn't quite, I don't know. We can also eliminate blueberry slice, since it's with apple slice, raspberry slice, and cinnamon slice. Okay, so as soon as you find one that does work, start to eliminate all the other ones that don't. Okay, and ultimately, if you work through the clues, you will end up with the correct combination there. So it is this packet is due on the 30th. Again, if you've got any other questions, please don't hesitate to contact me. And if you give it to me on the 29th to check over, then it's not going to be due for you until the 1st. All right, folks, that's how you math. Don't forget to like and subscribe. And happy Thanksgiving. Gobble, gobble.